In general, if R is a relation on A, we can draw a graph such that for any x and y in A, there is an arrow from x to y just in case x are y. Such a graph is called the directed graph of R. If the set A if this is a partially ordered set, its directed graph will be really messy because there will be loops at each point and there will be all the arrows resulting from the transitivity property. If we stack the elements of A as we did for the prerequisite relation, we can ignore the directions of each arrow since they all point upwards. If we further ignore the loops and all the arrows arising from the transitivity property, we'll end up with a much cleaner diagram. Such a diagram is called the Hasse diagram of the partial order relation. Here is the Hasse diagram for our prerequisite relation. Note that Math 356 is not a prerequisite for any other course. For all math courses X in A that are comparable to Math 356, X is less than or equal to Math 356. Such an element is called a maximal element of A. Okay, note that Math 54 is a prerequisite for every math course that it's comparable to. For all math courses X in A that are comparable to 54, Math 54 is less than or equal to X. Such an element is called a minimal element of A. An element y in A is said to be the greatest element of A if x is less than or equal to y for all x in A. Similarly, an element y in A is said to be the least element of A if y is less than or equal to x for all x in A. Note that in our prerequisite example, there is no greatest element of A. Let's go back to the diagram. Okay, Math 371, that is not the greatest element because it's not true that Math 356 is less than or equal to Math 371. Okay, neither is Math 356 the greatest element, since it's not true that Math 371 is less than or equal to Math 356. Also, there is no least element. Math 10 here is not the least element because it's not true that Math 10 is less than or equal to Math 54. And neither is Math 54 the least element, since it's not true that Math 54 is less than or equal to Math 10. If you recall our shorter than relation on the set A consisting of John, Bob, Mark, and Joanne, we had the Hasse diagram like this. In this case, the greatest element is John, and the least element is Mark. And you can see this here because John is greater than or equal to every other element, and Mark is less than or equal to every other element. So far, we've seen examples of partially ordered sets where some elements are not comparable. Let's now look at an example where all elements in a partially ordered set are comparable. In other words, let's look at an example of a totally ordered set. Okay, let A be this set, and consider the less than or equal to relation on this set A. Then we have that 3 is less than or equal to 6, which is less than or equal to 10. That's less than or equal to 11, and that's less than or equal to 35. So the Hasse diagram is simple. You have a straightforward hierarchy.